Fold-in form. Fold-in form is another close-fit type rehabilitation of pipe. It's a PVC product that is brought from the factory in this format that you see on the left-hand side of the left-hand side pipe, which is folded down, it's collapsed. It can either be collapsed like that into kind of a C format, or it can be collapsed down into a H format if it's a bigger roll. But it comes in a collapsed format, pulled into place into the hose pipe. Both ends are sealed. Then they interject steam and air into that to soften the pipe and then to blow it up into shape. Once it gets fully into shape, then they gradually cool it down, and then it forms a host inside the pipe. Then they go in and cut out the laterals robotically later on. It's not used that much. IPEX, the large pipe PVC manufacturer in Canada, has bought the franchise for it and is now starting to reintroduce it back into Canada. It was here 10-15 years ago. Fold-in form, so the fold-in form, we're talking about the premise liner. Here's the premise liner. Some photographs of the premise liner. It comes in a flat format from the factory. We roll it in half with some rollers and introduce it into the hose pipe, and then blow it up once it's in the hose pipe, and it pops back into place. It is essentially a more robust form of a lay flat hose, but as I said, very good for high pressure. The other thing we've got is high density polyethylene liner. High density polyethylene, if you go thin enough on it and you get into the DR40s, DR35s, DR40s, DR50s, it more or less is a lay flat liner as well, because it's a very thin pipe. Again, you can fold that down, introduce it in, and then let it pop back up again and become a closed liner. Or you can use high density polyethylene as a loose fit liner and introduce it as a rigid pipe. Here we go with a slip liner. Here's the loose fit high density polyethylene as a slip liner into a water main project. This is a rehabilitation of a water main project in North Burnaby a year or two ago. And it's quite a large diameter. The existing pipe was a 36-inch pipe or a 900mm pipe, and we brought in a 750mm high-density polyethylene into this pipe to rehabilitate it. This is a totally different type of slip lining. This is a slip lining with a rigid product. This is suitable for storm sewer situations and or sanitary sewer situations. This is a fiberglass pipe that is pre-made for this product, for this particular slip lining job. They're actually made in Dubai by a company called Channel Liner. Hobos is another manufacturer down in Texas. This pipe is shipped into the job after you've tested your existing pipe and you've proved the diameter and you're ordering the pipe to fit. Here's an example of the Channel Liner pipe being used in Victoria on a brick sewer line underneath the Ross Bay Cemetery. This is a very challenging job in that we only had one access point to this one. And there was a number of drops and bends on this one. But again, the Channel Liner pipe was able to be ordered in short enough lengths so that it would fit around the bends and fit around the vertical drops. Culvert rehabilitation. Culverts is something that exists all over British Columbia and all over Canada, in fact all over North America. We have approximately 30,000 culverts in the Lower Mainland and the Greater Vancouver area alone under highways. There's something that has probably been the poor brother of most rehabilitation processes so far. Most cities do have a handle on their culverts right now, but they're, as I said, they're probably the last ones to be rehabilitated. Here's what happens though when you don't rehabilitate your culverts. Here's an example of a culvert in Richmond that collapsed about 3 years ago on Highway 99 just south of the Oak Street Bridge. Here's the picture of that culvert on the inside. The face of the culvert we're looking at here is the north face, which is against the Oak Street Bridge. That didn't fail. But you can see right in the middle of the photograph that the corrugated steel seems to be gone. And it was, in fact. When we went through and tested that pipe after it failed, we found that there was one 2.5 meter section of pipe that I couldn't put a hammer right through. But the failure was very local. It was about that line that you see there, 100, 200 millimeters above that, and below that the steel was at full strength again. So it was a very local failure, but it caused a shear. That's the shear. That's the south side, which is what caused the failure, as you saw in the photograph 2 shots ago. So the crown sheared and fell inside the bottom section of the pipe, and that allowed the material to come in and allowed the road to collapse. Pipe wasn't going to come down completely, but it was going to come down about 400 or 500 millimeters, which of course is not not any good when the road is above it. Here are some culverts that we repaired or rehabilitated in Delta, down by highway, or by 112, where 112 crosses over the Highway 99. In fact, we did Highway 99 there. We did, this is Hornby Road, and we also did BC Rail, all in this zone, which is for Central Creek going through Delta. Here's another culvert rehabilitation methodology that we've been using, which is to reinforce inverts to the culverts. This is very suitable if the invert is gone, if it's an entrance control culvert. So generally, let me step back 1 second. If it's an entrance control culvert, meaning that the entrance is what controls the flow of water going through the culvert, then what tends to go is the invert of the culvert. If it's an exit control culvert, which is very common in Delta, Richmond, where there's standing water in the culvert most of the time, the area of corrosion tends to be about 9 o'clock and 3 o'clock, or thereabouts, 8 o'clock and 4 o'clock. And the inverts in those pipes can be in great shape. However, we have to rehabilitate. And so we're back into this area again, where we said two things about this culvert here in particular, let's say, is that as a vessel to contain water, it doesn't function anymore because it's got holes in the sides, so the water is percolating out into the ground, number one. Number two, as a methodology to maintain a structure, it has lost that ability. And so we're rehabilitating it such that it will have a structure, it'll be able to hold the ground open, and therefore the road won't collapse above it, number one. Number two, that it will contain the water and carry the water from one side of the road to the other without allowing that water to go into the road structure. So rehabilitating, when we do these rehabilitations of culverts, we're fixing two of the issues that we had at the very start. So here's an example of the finished product. You can see on the side here, the side was shotcreted on, the invert would have just regular concreted on, so you've got a cold joint where that white band in the concrete is. But that culvert right now is probably got about 70, 80 years of lifespan in it, and you're still utilizing, number one, the structure that was done initially, the tunnel that was done initially, and you're utilizing the existing corrugated steel at a much less cost than open cutting this project, plus the inconvenience of traffic to shutting down. Most of these are highways that you're trying to shut down. Also, because you have now a smooth bottom and smooth walls, you have increased the capacity on average 20-22%, because your N factor has gone way down.